In this section, we're going to take a look at some properties of exponents, and the first one is called the product rule, which involves multiplying two powers together that have the same base. And so if you recall, a power is of the form x to the a, where x is called the base and a is an exponent, and altogether x to the a is a power. So if I have two powers that have the same base and we are finding the product of them, then we just add the exponents together. And a numerical example is 2 to the third times 2 to the fourth. We can just add the 3 and the 4 together and get 2 to the seventh. Okay, the quotient rule says that if you divide two powers with the same base, you subtract the exponents. So a to the m divided by a to the n is equal to a to the m minus n. So 2 to the fourth divided by 2 to the third is equal to 2 to the 4 minus 3, or 2 to the first, which is just 2. Okay, now the reason behind this, if we did expand this power, so 2 times 2 times 2 times 2 is the same thing as 2 to the fourth, and then 2 times 2 times 2 is the same thing as 2 to the third, and we see how many of these factors cancel out. We're left with only one 2 in the numerator. So the next one is the power rule, which says if you raise a power to another power, you multiply the exponents together. A to the m to the n is equal to a to the m times n. So 2 to the third to the fourth is equal to 2 to the 3 times 4, or 2 to the 12th. Now the reason behind this property is we expand the expression. 2 to the third to the fourth is the same thing as writing 2 to the third 4 times. So 2 to the third times 2 to the third times 2 to the third times another 2 to the third. And then we use the product rule, which says to add those exponents together. So 2 to the 3 plus 3 plus 3 plus 3, or 3 times 4, which is 2 to the 12th. The zero exponent rule says that raise any non-zero number to the zero power and the result is always 1. So 2 to the 0 is equal to 1. Now the reason behind this, if we had 2 to the fourth divided by 2 to the fourth and use the quotient rule, we would get 2 to the 4 minus 4, or 2 to the 0. But we also know that when we divide a number by itself, we always get 1. So that means that 2 to the 0 must equal 1. The negative exponent rule, a to the negative n is equal to 1 over a to the positive n. So 2 to the negative third is the same thing as 1 over 2 to the positive third. Okay, now the reason behind this, if we had maybe 2 to the third divided by 2 to the fourth, and we subtracted the exponents because of the quotient rule, we would get 2 to the 3 minus 4, or 2 to the negative first. But if you just look at what these factors are in the denominator, we would have an extra 2. So we would actually end up with 1/2 by just canceling out the common factors. And so 2 to the negative first is the same thing as 1 over 2, which is the negative exponent rule. The power of a product rule, a times b to the n, you raise both of those factors to the nth power, a to the n times b to the n. So 2 times 3 to the fourth. One option is just to take 2 to the fourth and then raise 3 to the fourth and evaluate. So 2 to the fourth is 16, 3 to the fourth is 81, and multiply them together, you get 1,296. Okay, the probably more convenient option in this case is just to multiply 2 times 3 first and then raise to the fourth power. And then the last one, the power of a quotient rule, says that you raise a fraction, raise it to a power, you're going to raise both the numerator and denominator to that power. So 2/3 raised to the fourth, we raise 2 to the fourth, and 3 to the fourth, and then simplify. So 2 to the fourth is 16, 3 to the fourth is 81, and 16 over 81 is our answer.